Good day, students. Today we want to discuss on the relationship between atomic number, mass number, proton, and the neutron. The mass of the atom could be concentrated, could be said to be concentrated at a small center called the nucleus. Okay. The mass of the atom is equal to the total number of the proton and neutron in the nucleus of the atom, and is called the mass number, and is represented by the symbol A. The mass number A equals number of protons plus number of neutrons. What you are saying is that when you are in an atom like this, sodium atom, we have sodium atom. That's a 281. You have proton and the neutron at the center of the nucleus. When you have proton and neutron together to give you mass number, we are told that it's concentrated at the center of the nucleus and is the mass number of the atom. That's why I said that mass of the atom could be said to be concentrated in the small center called the nucleus. Why? Because the weight is being experienced at the center, because proton and neutron is inside the nucleus, while the electron revolves around the nucleus. See, 2, 8 is 2, 4, 5, 6, 7, 8. 2 in the innermost shell, the falling shell 8, and the 1 at the outermost shell. Okay. In the sodium atom, you could see that the number of proton is the same thing as the number of electron, which is 11. As proton equals 11, neutron equals 11, and electron equals 11 in sodium atom. But when it loses this one electron to become sodium ion, 1, 2, 3, 4, 5, 6, 7, 8. Here it becomes sodium ion, which is 2, 8. So I was giving this one outermost electron to electronegative elements. For example, let's say chlorine. 1, 2, 3, 4, 5, 6, 7, 8. The outside one, 1, 2, 3, 4, 5, 6, 7. This one electron here will be joined to the, before it is 2 chlorine atom is 287. When you now gain electron from the sodium atoms, you form 2H. At that point, when it gains the one electron, chloride ion will now be 288. When you are giving sodium ion like this, you see positive and you have 2311. If they ask you what the number of proton is 11, number of neutron is 11. So the number of proton is 11, atomic number is 11, neutron is 23 minus 11 as 12, neutron is 12, and then number of electron is 10 because it has lost the one electron here. Now you come to chlorine. Chlorine, you have, let me write it here, chloride ion, having 35, 17 is an isotope. Chlorine is an isotope. You have 37, that of 37 and 17. An isotope are elements that have the same atomic number but different mass number. Now let's see this chloride ion. The atomic number here is 17. Proton is 17, electron is 18 because it has gained one electron to become 288. Okay, but under atom the proton is under atom when there is no negative ion 1735. Proton is 17. Electron is also 17. Atomic number is 17 under atom, chlorine atom. Is that okay? And if you want to get the neutron, 35 minus 17 to give you the neutron. Borrow one from here. 15 minus 7, that's 8. Anyone, that's 18. Neutron is 18. Okay, now that's what you need to know. And if you want to write want to show us how it's being formed. This sodium is being formed. You can have it when it loses electron, sodium atom or sodium ion plus electron. When it gains chlorine, chlorine atom gain this electron from the sodium when it loses it out plus electron. Is that okay? This 287 plus 1 electron will give us chloride ion. Take note. Chloride ion, chlorine becomes chloride ion when it gains the electron from the sodium. That's why I see I didn't put negative here, but when it gains it becomes chloride ion. Now let's continue. Atomic number equals number of protons. Okay, right here. The number of protons alone in the nucleus of the atom is called the atomic number, and it is represented by the symbol Z. Atomic number Z equals number of proton. This number of proton. A minus Z equals number of neutrons in A, Z, X. This X stands for elements. A stands for mass number. Okay, mass number, not atomic mass, mass number. Z stands for atomic number. This mass number, atomic number. A minus Z equals the number of neutrons in this. The atom is electrically neutral. Hence, the number of positively charged protons equals in the nucleus must be equal to the number of negatively charged electrons outside the nucleus. What you are saying is that you can see number of protons here is 11 in sodium, and it must be equal to number of electrons outside this nucleus, which is the 11. They are the same. Is that okay? When they are electrically neutral. But when they are electrically charged, electrons either reduce or increase. Under metallic ion like sodium, metallic element like sodium, it's reduced, electron reduced, but atomic number and protons still remain what it is. Chlorine, under chlorine, which is electronegative element, the electron increases when it becomes electrically charged. Okay, now we have to the atom is electrically neutral, hence the number of positively charged protons in the nucleus must be equal to the number of negatively charged electrons outside the nucleus. Number of protons equals the number of electrons. We have to interpret this. Interpret the atom of the element represented as mass number equals to 23. This 11 is atomic number. Atomic number equals to number of proton, because it's electrically neutral, equals to number of electron, which is equals to 11. number of neutron equals 23. Mass number minus atomic number, which is 12. Okay, Na equals elements equals sodium atom, which is electrically neutral. Okay, this is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.